Okay, so new stuff. Not really new stuff. I mean, just kind of connected stuff. A lot of this is going to be review. What we want to do today, we're going to start looking at solving equations. And here's the context we can use for that. If we were going to, let's just take a quadratic function. Let's say we had something like, let's say we had f of x equals x squared minus 2x minus 3. Okay, and we want to do a sketch of this thing, right? There's a lot of stuff we could do. We could find the vertex, right? How would we find the vertex?
Never mind.
No, you do. Go ahead. I bet you do. The vertex is going to be HK, right? So we got to find out. We got to be able to fill in those blanks, right? How do we find H?
H is equal to negative b over 2x.
2a. Very good. Negative b over 2a. Good. So we know H is negative b over 2a, which would be what? 2 over
X.
2 times 1, which is 2. So it's 1, right? So we know H is 1. If we want to find K,
Go Bucks.
go Bucks. Yeah, exactly. You like that? Yeah. This is the kind of stuff you learn at teacher school. You see, it's really, don't try it at home. So what do we do? How do we find K? Plug it in. Yeah, it's f of h, right? Because K is the y value of the vertex. To find a y value, we plug in the x value into the function. So we get f of 1, and what's that going to give us? 1 squared minus 2 times 1 minus 3. So 1 minus 2 is negative 1, right? And then, is that right? 1 minus 2. Negative 1 minus 3 is negative 4. Okay. Okay, good. So we got it. There's something good. And we could sketch the graph because we know what A is, right?
Well, what's this called? Finding the...
We just found the vertex. Okay, so if we were going to sketch this thing then, we know that we would go over 1 and down 4. Let me speed this up a little bit. How about? And
On
that's
this,
gonna
negative
be-
3 is the final answer, right?
Say it again.
Negative 3 is all you need. That's what you're trying to find.
Well, we were trying to find this point, right? We're trying to find the vertex. So the vertex is at the point over 1 down 4. So there it is, right? And we know what A is. A is the vertical dilation factor, so we're not stretching, we're stretching it by once. We're not stretching it at all, right? So we could sketch some points and create the shape of this thing, and that's what we've done so far. What's some other stuff we could do? How about the intercepts? Those are oftentimes really important things to find. If we want to find the y-intercept, what do we know about that? It's on the y-axis, right?
Yep.
Every point on the y-axis has what in common?
Same.
0,
As the
Y.
X.
x coordinates. Yeah, right? Because think about that.
Yeah.
That makes sense? I mean, x and y, that's just a roadmap for an ant going to a point. If he's going to go to this point right here from the origin, we're going to tell him go down 4, and we're going to go to the right by 1, because that's the x coordinate. Well, if an ant's going to go to a point on the y-axis, he doesn't have to go left or right at all, just up and down, right? So that makes sense? So all we'd have to do then, we know if we want to find the y-intercept, we know x is 0. We just got to find the corresponding y value. So if we know an x value, what do? We want to find a y value every time.
Plug it in.
Plug it in, right?
There you go.
So if we want to find the y-intercept then, that's just going to be at f of 0. Well, look what that is. That's easy, right? When we evaluate something at 0, it's a piece of cake because look what happens.
3.
Any term that has an x in it, it's going to go to 0. So that's 0, that's 0. What's left?
Negative 3.
Negative 3. So that's easy to find, right? Y-intercepts are a piece of cake. You just set x equal to 0 and evaluate the function, right? No big deal. So what about x-intercepts?
No big deal.
A little bigger deal.
I can't buy it.
What's gonna happen at each of the x-intercepts? What has to be true there? Y is 0. Okay, what's that mean? Well, for our function, f of x is equal to y, right? Does that make sense?
0?
So yeah, so we're gonna set the whole thing equal to 0. By setting f of x or y equal to 0, what we're really doing is we're creating the equation x squared minus 2x minus 3 equals 0. The solutions of that equation are gonna be the x-intercepts, right?
So you gotta add 3.
So, well, okay, so that's what we're getting to then, right? So that's where we leave off. So we're at the point now where we gotta go back, and you've done some of this in Algebra 1, but I'm just not certain that the context was probably, you know, I mean, this is a more complete context. I think you'll really get this when we go through it this year. So, solutions of that equation are the x-intercepts. So we end up then with this equation, right? Here's our equation that we're trying to solve. Okay, let's talk about solving equations. We did a lot of review at the beginning of the year about solving equations, and I said something really important. I told you I'd say it a lot. We've done so much graphing stuff here now that we really haven't done a lot of algebra, right? What did I say about if I can point to a single x in an equation, I can always isolate it, and that means solve, right? Our point is just to get the x by itself. But look here, do I have a single x I can point to? No. I've got an x squared term and an x term, and I can't combine those. They're not like terms. So I'm stuck with two different instances of x in this equation, or two different examples of an x. So I can't do that. I have to do something different here. We'll come back to that. That's one type of quadratic equation that we're going to have to deal with, and we will. But for today, let's just look at the kinds of quadratic equations that we can solve by isolating. First of all, why is this a quadratic equation? What makes it quadratic?
The square?
The square, yeah. It's not this term or this term. We could either have an x term or not. We could either have a constant or not. But for this to be quadratic, it has to have an x squared, doesn't it? Right? Okay, so let's try something maybe like this guy. Is that the wrong one? No, okay, skip one. Oh, there's another one right there. Okay, so let's try this now. How many x's are there in this equation? 1. Okay, there's one x, so I can isolate it. I can point to it, so I can isolate it, right? So this is our goal. I want to isolate that x. So how do we do that? You know, when we want to isolate a variable, that's just an order of operations thing, right? We said that we simplify by using our order of operations tree. We simplify by going regular top down. But to isolate, we flip it around and we go bottoms up, right? So what's the first thing we'd have to do then? Step 1 is what? Add, subtract. So what are we going to add? 20. Yeah, add 20 to both sides, right?
Oh.
So step 1 is we're going to add 20. And that's going to give me 4x squared equals what? 392. Okay. Now what about step 2? What's that stand for?
Multiply and divide.
Multiply or divide. What do I need to do? Do I need to multiply or divide to get that x by itself?
4.
Divide by 4. So step 2, we'll divide by 4 and get x squared equals 98. Okay? So now, what about step 3? That's a weird one. Exponents, yeah, so there is an exponent there, there's a squared. So this is where I have to undo that exponent to get the x by itself, right?
So do you divide 98 by...
What are we gonna do? How do we, so we've got to, think what we
Divide it
did here, we undid the subtracting 20 by adding 20, right? Because those are inverse operations, right? We undid the multiplying by 4 by dividing by 4. because dividing and multiplying are inverse operations.
But exponents doesn't have an inverse
It
operation.
doesn't? What's the inverse of squaring something?
Dividing.
Square rooting. Yeah, right? Think about that. 4 squared is what?
2.
No, 4 squared.
8.
16. What's the square? What's the square root of 16?
4.
Undid it, right? It reversed that operation,
Ah.
right? See what I'm saying? Okay, so the next step here then, step 3 is we're going to square root to undo the squared, right? Now I want to show you something here though, that now watch this closely because this is, we don't do this every time, but you probably remember back in Algebra 2 that when you took a square root of both sides of an equation, you always ended up having to include a what?
Exponent.
No?
Square root sign?
Yeah, I mean like if I had something like x squared equals 4, what'd you get for your answer? X equals,
2 squared.
well,
I don't know.
I mean, like, here's what I'm saying. If you have something like, if you're solving this, x squared equals 4, what do you get for a solution when you
Oh,
square root?
16.
You square root both sides.
Oh.
2, but that wasn't the whole answer. There was something else you had to include.
Over 1?
Remember that?
Oh.
Plus or minus? Vaguely, you remember that?
Yeah.
Okay, you forgot it though. And this once again proves my point that memorizing little facts doesn't do any good. They just go away because they're not powerfully connected to your brain. There's only a couple little weak little dendrites and axons making those connections in your brain, and they get recruited away for other stuff. And so that stuff goes away with everybody. It just does. But instead, if you can connect it to a bigger concept, you will never forget it because there's more parts of your brain that are activated and there's more of these little connections. And so it's a more powerful memory. It's more powerfully ingrained in your mind, right? So let's do that. Let's not just remember that you include a plus or minus. Let's talk about why you do it.
Because you're not
So-
sure if it's positive or negative.
Say it again.
You're not sure if it's positive or negative.
Right, and we know they would both work, don't we? Because think about that. Positive 2 squared is 4, but so is negative 2 squared, right? So we can kind of see that they have to be there, but why? Here's why it happens. If we look at the algebra, so if I square root both sides, and that's step 3, right? If I take the square root of x squared, that's equal to the square root of 98. Okay, but let's think about this now. What is the square root of x squared? Let's think of that as just being some function. So if we, okay, lose that color. So let's just call this g of x or something. So if g of x is the square root of x squared, right? Let's try this function out here for a second. Let's evaluate the function at 4. What's g of 4? Well, that's just going to be the square root of 4 squared. What's 4 squared?
2.
Squared.
16.
16.
Yes.
Square root of 16? 4. So look what happened there. I input a 4 and it output a 4. Okay. How about let's try something different. What if we do g of negative 4? Well, that's going to be the square root of negative 4 squared. What's negative 4 squared?
16.
16 equals
What's the square root of 16?
4.
Okay, now what happened? We input a negative 4 and we output a positive 4.
well, you can't.
That's okay. That's what it does, right? That's what this square root of x squared function does. But what function do you know that does that exact stuff? If I input a positive number, it leaves it
Absolute
alone.
value.
What was it?
Absolute value.
Absolute value. Yeah, that's it.
To
Right? So the square root of x squared is truly the easiest way to say that. That's the definition of the absolute value function, right? So what we've really got up here, when we square root both sides, the square root of x squared becomes the absolute value of x. So we end up with the absolute value of x equals the square root of 98. Now we've had some practice solving absolute value equations. If the square root of x equals some number, then what could x equal?
X.
Positive or negative, right? That's our pattern, isn't it? If we isolate a square root, if an isolated square root is equal to a number, then whatever's inside the square root either equals the number or its opposite, right? That's how, and you're doing, what is that, section 3.1. You got some practice on that. Well, now we're putting it to use. So this gives us either x equals square root of 98, or x equals, that's just an or x equals negative the square root of 98, whatever that is, right? So then we could just say, well, what do we get then? X equals plus or minus the square root of 98. Do you have to show that work every time? No, you can just skip down to there. But that's why it happens, right? Because when you square root both sides, you're actually creating an absolute value function, which reminds you that you need that plus or minus, okay? And then this one just wants us to round your answer to the nearest hundredth as a decimal, so I would just throw that in my calculator and get a number, right? Like 9.9 something, what we're gonna get back, okay? Make sense? No biggie. Okay, what about something like this? Same kind of thing, right? What's the first step if I want to solve for x here? By isolating. And I can isolate because there's a single x. What do I do?
Add 7.
Add 7. So that's just going to give me, what, negative 98?
Then you got a square root.
Square root both sides. Okay, so then I get x equals plus or minus, right?
What if you forgot how to square root?
What's that?
What if you forgot how to square root?
Well, you're going to get some practice.
Oh,
Because
good.
we're definitely going to be doing that.
That's the last thing we did freshman year, and
It's been a while.
It's been a while. Yeah, that's okay. We did a little bit of that at the beginning of the year, remember, with our chart over there, simplifying radicals. But you'll get some more practice. It's not a big deal. What you find with math is stuff that seemed complicated a while ago, you come back to it and you've evolved as a, your mind you're just better and it's easier. Why did I make that negative red? That's important.
Because the
Taking the square root of negative 98.
you can't do that.
Can't do that, right? For real numbers, we can't do that. There's only 2 rules for real numbers. You can't divide by,
Negative,
no.
positive.
What number can't we divide by? 0, right? And we can't take an even root, so a square root for us now. That's all we're dealing with. That's the only even root really we're working with now. We can't take a square root of a negative number.
Because if it was cubed, you could, because that's 3.
You could, yeah, the cube root of negative 8 is negative 2. Think about that. Negative 2 times negative 2 is positive 4,
If it's odd,
times negative 2 is negative 8.
Yep.
So if it's an odd root, you can, but an even root, you cannot. Okay, so this is one, based on the directions for this problem where we're only looking for real solutions, what would I input in Moodle? Well,
And
n.
no real solution.
Okay, so
A
we're just
red
gonna put an n. Okay.
We get red.
All right, what about something like this?
Oh, I know how to do this. I can solve this by myself.
Okay, what are you gonna
Subtract
do?
12, then you divide 4.
So what do I do with the 12?
Subtract.
Subtract 12, good. So that's gonna give us 4x squared equals 16.
Then you divide 4.
Divide by 4, good.
I could even that.
So I get x squared equals 4, so x equals
Well, you gotta square root it, and then it'd be 16. Oh wait, no, it'd be 2.
2, okay? What do I need though?
Plus
Plus or minus, there we go. We gotta have that plus or minus there. And we just know that whenever we square root both sides of an equation, we have to introduce that plus or minus, right? Okay, let's try a harder one. How about something like that?
So I can solve this by myself. This
All right,
goes-
let's see. Now I'm gonna put up the order of operations tree. Let's see this.
Come on, see it happen.
All right.
Why it's on a
See
roll.
it happen. Yeah, he said he doesn't need it.
Doesn't need it? Oh, okay, well, too late. So
All right.
what's step 1?
Add 2.
Okay? So step 1, we get negative 3 times the quantity 2x minus 4 squared equals negative 48.
All right, and you divide negative 3, right?
Ah, good, good. So step 2, we'll divide by negative 3, and that's going to give us the quantity 2x minus 4 squared equals negative 48 divided by negative 3
But I have a
is...
question. Like, why wouldn't you distribute the negative 3?
You can't because it's not that simple because this is being squared, right?
So you can't distribute. when-
Well, okay, so it's a good question. So let me, it's a real good question. I really want to answer this because I think a lot of people probably have the same question. Why can't you do that? Okay, you can't do that because what is 2x minus 4 squared? It's not just 2x squared minus 4 squared. If I were to expand all that out, think what we're going to get. And this is good practice. If I'm going to expand all that out, just this part right here, right?
So you get
2x minus 4 squared is going to be 2x minus 4 times 2x minus 4, right?
So then can you do?
So, well, yeah, I mean, now, I mean, I could, but then look what I've done. If I do this stuff, I want you to tell me why this probably wasn't a great strategy. Because math is, more and more, math is about strategy. Like in calculus today, we did very little math, but almost the whole time, we just talked about strategies. I mean, I always tell my guys in calculus, you're going to screw this up if you don't take a couple minutes and really think about this problem before you do it. Because you could go down a road where the calculus is just boards and boards and boards long, or if you're smart about it, you maybe could choose a different strategy and do it very quickly, right? So it becomes kind of like a game, like a strategy game. And so let's play this one out, because then you'll file this away and you'll be thinking strategically next time. If I were to multiply this out, if I distribute the 2x, I'm going to get 2x times 2x is what?
4x
4x
squared.
squared.
Oh, you're gonna have a bunch of squared stuff.
Distribute the 2x to the negative 4,
Negative 8 squared,
negative 8,
x squared.
just x this time, right?
Oh,
2x
yeah.
times negative 4, okay? Now I'm going to distribute the negative 4 to the 2x and get another
8x.
negative 8x, and then negative 4 times negative 4 is
4x.
16.
What?
And I could combine like terms, right? And I could just get 4x squared minus 16x plus 16 is what all that stuff becomes. So now that I've expanded it out, I could distribute the negative 3 through that thing, right? But that's not what I would have gotten. If I had distributed right now, I would have gotten negative 6x plus 12 squared, which is nothing remotely like that, right? You can't do it because this squared hasn't been done first. If you think about it in terms of order of operations, here's another way to think about that. And I think this is, putting all this stuff together, really, then you really start to get math.
So you technically can do that, but it's really, really, really long.
Well, okay, I mean, you'd have to expand it out first
Mhm.
before you did it. Because then, I mean, normally, if we were just trying to simplify that side, which is what you're really trying to do, we have to take care of parentheses and exponents before we could multiply the negative 3, okay? But then if we did all that stuff, look where that gets us. Now we're kind of in a bad spot because now we no longer have a single x to isolate, right? So we got to go to a harder strategy.
Yeah.
So we're actually better off just reversing order of operations and whittling away at the left side until we just get an x by itself. Okay, make sense? Okay? All right, so going back to this then, we'll divide by negative 3, and that gives us, once again, what is negative 48 over negative 3?
18?
Close?
16.
16, positive 16. Okay, so there was step 2. Now what's step 3?
Exponents.
Exponents. So we're going to square root both sides, right?
4.
So step 3 is going to undo the squared. So I'm going to get a 2x minus 4, and then over here, but, oh, plus or minus. Good, I got to have that plus or minus because I square rooted both sides, right? So I get plus or minus 4. Now notice that I didn't write the parentheses in there. Those are sort of optional at this point because I don't really need them. In fact, I would say they're not even optional. You get rid of them. Here they were important because it told us what was being squared. Sometimes they're important because they tell us what we're multiplying, what we're distributing through too, what we're multiplying everything by. But here there's nothing being done. There's a 1 out front and a 1 up there, so we could get rid of them at that point. But it does take us up to the last step, which is inside the parentheses. So finally, now we're inside the parentheses, and this is easy. What are the 2 steps in order to isolate x now?
Got to add 4
Add 4 and then
by 2.
divide by 2. So step 4 would just be kind of a combined thing. We get 2x. Oh, but I want to show you something important here too. There is a big deal with this. So when we're going through this last part, I want you to notice I've got this plus or minus in here. Okay, whenever I do something like I'm going to add a term to both sides now, so I'm adding 4 to both sides, always put it in front of the plus or minus. I'll show you why. It makes it really easy. If I were subtracting something from both sides, subtracting a number is the same as just adding a negative, right? So say I were subtracting 4 from both sides, I would just put a -4 in front of the plus or minus. Okay, look what this does when we do that. Then we end up with 2x, because that's gone, equals 4 plus or minus 4, right? Last step you told me was divide by 2, right? So if we divide each side by 2, then we end up with x equals 4 plus or minus 4 over 2. Okay, this is a good way to do it, because now look what happens. If we take the plus sign, that tells us x equals what? 4 plus 4 is
8.
divided by 2? 4. So one solution is x equals 4 if we use the plus sign. What if we use the minus sign?
0.
4 minus 4 is 0, divided by 2 is
0.
0. See how that works?
Okay.
It's a lot easier to do that if you plug that number in front of the plus or minus, I think.
So that's how, what would you put in that?
So, okay, so in Moodle, let's go back. What would we put in Moodle? So it says if multiple real solutions exist, separate them with commas. So in Moodle, what would I do? I would just put 4 comma 0 in either order, it doesn't matter. Because I get 2 separate solutions for x. Okay? All right, last one. All right, so what about,
How to build business.
I think it's the last one. Yeah, last one. What about something like this? Okay. So same kind of a deal, right? This is no harder than the last one. Let's rehearse the steps. Let's just go through these in order. If you kind of think in terms of isolating x, what's the first thing I'm going to do?
-1.
Subtract 1. Then what?
Divide by -3.
Divide by -3. Then what?
Square root.
Square root. Then what?
Add 5.
Add 5 in front of the plus or minus, and then
Divide by 3.
divide by 3. No big deal, right?
Easy money.
Okay, so let's go through that stuff. So if I subtract 1, I get -3 times the quantity 3x minus 5 squared equals -294, right? If I divide by -3, I get 3x minus 5 squared equals negative, divided by negative is positive, and that's going to give me 98. Okay? Now what?
Now you gotta square root it.
Square root it. So I'm going to get 3x minus 5 equals plus or minus. Good.
Why are we always getting 98?
I don't know. It's just weird. That's really, I mean, you won't, trust me. It's just weird that it came up so many. Yeah, I just pulled up random sample problems. Okay, but notice the instructions are different this time. It's not telling us to round your answer to 2 decimal places. It's telling us write your answer as exact solutions in simplified form. So we don't have the option. A decimal is not going to be exact here, right? We need to write this as a simplified radical. So we got to go back and review for a second. How do we do that? How do we simplify? If I want to simplify the square root of 98, can I? The only way we could is if I can find a perfect square factor of 98, because our goal to simplify a radical is to get as much of the number outside as possible. Well, here's our list of perfect squares over here. Is 98 a perfect square? No, it's not.
9 point something.
It'd be 9.99, something like that, right? It's going to be a decimal. So then we can start looking for perfect square factors. Well, you don't need to look at anything bigger than half of the number. So you'd start with half the number and just work your way down. So half of 98 is what? 40.
No, 52. No, I ain't close. 46. 49.
49.
Jeez,
That's 49, right? So half of 98 is 49, so we'll just look down there and say, well, actually 49 works, right? 49 is 7 squared, so the square root of 49 is 7. But if it didn't work, we would just keep on moving up the list and find the biggest one we could that's
So
a
would you
perfect square
cut
factor.
40, like let's say you got 48, would you cut that in half?
Yes.
Okay.
Right. No, you mean if we started off with 96?
Yeah.
No, then we'd go to 48. That doesn't work. And so then we'd work our way up. Does 36 divide into 98? No, it doesn't. Does 25? No, it doesn't. Does 16? No, yeah, it does.
Okay.
Yeah, so that's one that would work, okay? So then what we gotta do here, now let's look at this last part. So we're saying, okay, the magic number here is 49, right? So the square root of 98 is the square root of 49 times, wow. Get so excited to show you this, I just can't contain myself. So 49 times 2, right? So then I'll just break that into separate square roots. I'm gonna put the perfect square one first, because that's the part that's gonna get out of the square root, isn't it? The square root of 49 is the good part. Oh, gosh, darn it. Why this thing doesn't work as well this year. What is the square root of 49?
7.
7. So there's my simplified answer, the square root of 98. 7 radical 2. So we got a lot of that big number outside. We're stuck with the 2 though, okay? So now we can go further with our solution. So this just looks like plus or minus 7 radical 2. Okay, so what are the next steps in order to get the x by itself?
Add
Add 5, so where's the 5 go?
in front.
Good,
Front of
in
the
front.
X.
Good, so we're gonna add 5 to both parts, and that gives us 3x equals 5 plus or minus 7 radical 2, and then I'll just divide through by 3, and I get this answer. Okay, now let's get in the habit though of not writing this with the common denominator. Let's write it separately. So this is equal to 5/3, because I'm going to split my denominator into both fractions, right? So 5/3 plus or minus 7 times the square root of 2 over 3. I've got some other reasons for doing this. One reason is that sometimes one of these fractions will reduce, but the other one won't. And to have it fully simplified, you got to reduce your fractions. The other reason I'm doing it, I'm not going to bother you with right now. It has to do with complex numbers and imaginary numbers and things. This will help in the future to get in this habit. Just trust me on that one. But those would be our 2 answers. So how do we put those in Moodle? 5/3 plus 7 radical 2 over 3, comma, 5/3 minus 7 radical 2 over 3. Okay, that's it. That's what we go in Moodle.
That's what's, okay. I was gonna ask, yeah.
Okay, make sense? All right. Do we have any time?
9 minutos.
Go, work. There's an assignment up. Go for it.
I didn't understand that.